In this lesson, we're going to be looking at how we use reasoning in geometry class. Really what we're looking at is how to prove things in a way that makes sense to other people and that is very clear. Now we're going to start that by using algebra properties, because you should be familiar with those algebra properties already. Now we're going to be using those algebra properties in geometry, and they're going to help us solve problems, but we have to justify each step. So we're going to start just by a quick review of algebra properties where A, B, and C are any number. And first we have the addition property, where if we have an equation, the addition property says we're allowed to add to both sides of the equation the same thing. Okay, so we're keeping it equal if we add the same thing to both sides. Subtraction property is the same thing. If we add it, subtract from both sides, it's still equal. Multiplication property, same thing. We're multiplying the whole side by the same number, it's still equal. Division property, same thing, with just a little extra note about not being able to have a zero on the bottom, not allowed to divide by zero. There's some other properties we have with the reflexive property, where we're saying the exact same number on both sides. This is like saying 3 equals 3. If it's not exactly the same thing, it's not reflexive. We think of reflexive like a mirror, so it's kind of like we're seeing the same thing back in the mirror. Symmetric property is when we're able to flip it around. So if A equals B, that means we can flip it around and say B equals A. Transitive property is kind of like a train or a chain where we're connecting parts, but then we cut out a middle step. So A to B and B to C, that means A must be equal to C. Substitution property is if we have an equation that we know the two parts are equal, well, we can put B and replace it in any other equation. So if, for example, I know that x equals 3 and I have an equation that says 3x minus 7, I can say that's equal to 3 times 3 minus 7. And there's no problem with that. That would be substitution. Okay, the next property is the distributive property. We also had this in algebra. This is when we can multiply in. Just make sure that we're multiplying in to each part. So if I have 3 times x, it would be 3x minus 7. I need to make sure that 3 is multiplied by everything, that we keep the sign there, minus 21. So here's an example of what this might look like. Basically, just justifying steps when we solve an equation. So what's the value of x? So we look at this first of all. We look at the picture. The pictures are important in these. And we notice this is forming a line, so we should recognize that those parts are supplementary. Well, why do we know that they're supplementary? We have to justify that. And we can see that there's a linear pair here. They form a line, and we know that a linear pair is supplementary. That's something we saw in chapter 1. Okay, so using that information, we want to use definitions that we know. What does it mean to be supplementary? So we're just defining supplementary. The definition is that those two angles are going to add up to 180. Notice how they're using an M for measure of. We have to do that when we're using addition and equal. Now, looking at the picture, we can see AOM is also 2x plus 30, and MOC is x degrees. So we can put those in there. Why? Well, we're doing a substitution there. Okay, in the next part, we look over, here we combine 2x plus x. Now, what this is doing, we're only simplifying one side of this. So what are we doing? We think of that as addition, but addition property talked about adding to both sides. Really what we're doing here is just another substitution. We're saying that 2x plus x equals 3x. In our next step, we want to subtract 30 from both sides. That is the subtraction property because it's affecting both sides. And then we divide from both sides. Okay, so division property of equality is from both sides. So we found an answer here, x equals 50. And we're done. We've justified every step. Now we can also use some of these properties with congruence also. We talked about reflexive, symmetric, and transitive. And for segments and for angles, these are also going to be true. So any segment is congruent to itself. The angles are congruent to themselves. Symmetric property, same deal, where we can use congruence with those. Notice we're not using any addition or subtraction here because equality uses addition and subtraction, but we can't do that with congruence. Okay, so let's look at identifying some of these. What are we doing? First of all, we ask, are we using congruent or equality? These are equality because we're using equal sign, we're using addition. Well, what we've done here, we subtracted 9 from both sides. That's the subtraction property. And the next one, well, we're looking at congruent first of all, so it has to be a property of congruence. We look at what we've done, we'd say in congruent, O is congruent to W, angle W congruent to angle L. Their conclusion, and they left out the W. So looking back at our properties, that's the transitive property. We have three things, we leave out the middle step and just connect the two on the outside there, the transitive property. The next one, notice we're using equals, which uses the measure of the angles. And all they've done is switch the order. That was our symmetric property. Okay, the next part we'll be looking at is something called a proof. In a proof, we're going to use, basically we want to make a convincing argument. It follows steps very carefully so that anybody can follow it. Mostly we're going to be using what's called a two-column proof, where we put statements on the left and reasons or justification on the right, explaining why we're allowed to say this. Now there's a couple things that I will always expect you to have for this. Before you even start your proof, you need to copy down what you're given, what we know, and what we're trying to show follows from that, what we can prove from that. In order to do that, we often need to have a picture. If we don't have the picture, this AEC and DEB won't make any sense because we don't know where they are, we don't know how they relate to angles 1 and 3. So I need a picture that's labeled so that it goes along with this. If you don't have that, you're not going to get credit. Now we begin our proof then. We usually start, not always, but we'll often start with what's given to us. And the reason that we can do that, our justification is just, it was given to us. We know this is true because it was given. Everything else that we put are going to be some of those rules, those properties that we saw earlier. But when we get down to the bottom, what we should have for our final statement is whatever we were told to prove right here. That should match. And once you've reached that, you know that you've completed the proof. Okay, so here's an example of writing a two-column proof. We're given that angle 1 is congruent to angle 3. Okay, that's here in our picture. And we want to prove that angle AEC is congruent to DEB. Notice we haven't been told anything about angle 2. But we want to show then, if we're trying to show that these angles are the same, then what we should recognize is, well, they're both sharing angle 2. So if I add 1 and 2, and 1 and 3 are the same, then 3 and 2 should be the same as 1 and 2. So we need to have a kind of systematic way of showing that. Now usually our first step is just going to be repeat whatever was given to us. So it should be some easy points whenever you do a proof. Okay, next we want to think about that angle 2 that we talked about, that they're sharing. Well, why can we say that these are equal to each other? We have to give a reason for that, and that's why we use the reflexive property of equality. For our next step, we recognize that, well, we knew that 1 and 3 were equal to each other. So basically, we're bringing this step down here, and we're combining it with what we know in 2. We're adding the same thing to both sides. That's the addition property because we're doing it to both sides of the equation. Well, the next thing we want to do is recognize that angle 1 and angle 2 are going to give us one of the angles we're looking for, AEC. And also angles 2 and 3 are going to give us another angle we're looking for, BED. And that's the angle addition postulate. That was something we had in the first chapter. So we're going to have to remember some of these names. Or if you don't remember the names, sometimes you can just say what the postulate is about. Okay, after we've done this, we know 1 plus 2 is equal to 3 plus 2. We also know 1 plus 2 is AEC. So for this part, I can substitute AEC instead of writing 1 and 2. So again, what I've done is I've just taken this step 3, moved down here, but I'm substituting what I know right here. For the second part then, the 3 and the 2, angle 3 and angle 2 from right here, I'm bringing them down, except I'm substituting in what I know about angles 2 and 3, so that gets brought down, and they're equal to each other. Why? Because we just substituted there. At this step, we recognize that we have exactly what we were asked to find up here. We've justified all of our steps, and so we've finished. We've proven that these two angles are equal to each other.